All right. This is the lesson on trigonometric ratios that was already posted in its learning. There's your homework 4 that is technically due today, but you have an extension. Let's go on to solving solving right triangles. Now, I don't have a calculator, so I'm going to set things up for you, and you got to finish them up with your own calculator. We've already talked about trig ratios. So if I'm looking for, in this case, they want me to find the values of x and round to the nearest tenth. So you're going to do that part with the calculator. I'm going to give you the exact answers. I'm looking for x, and the value that I have been given is an angle of 32 degrees and another side. If you think about it, that missing side, x, is the hypotenuse. That's the hypotenuse of that triangle. And since I'm looking at 32 degrees and across the street from 32 degrees is the 11, that would be my opposite side. Therefore, the side that's not labeled is my adjacent. I may or may not need that. So a trig function that connects 32 degrees with the x and the 11, since it's an opposite and a hypotenuse, I will use sine. Sine of this angle, not any other angle, just this angle here, is equal to opposite over hypotenuse. Now I got to get x by itself, so I will multiply both sides by x, which cancels out the x, leaving x times the sine of 32 degrees is 11. One more step, divide both sides by the sine of 32 degrees, divide by sine of 32 degrees, sine of 32 cancels there. There's my answer. There's my exact answer. 11 divided by sine of 32 degrees. Now, I have to remind you that we're in degree mode, and on your Inspire, when you first reset them and turn them on, they're usually in radian mode. So you're going to have to go to the, if you have a question, you can message me on Remind, and I will send you a video to how to change your Inspire to degrees. There's a setting on it. But right now, you key that in to get the approximate answer, but you will get the wrong answer if you don't have it in degree mode. Maybe I'll post a video in its learning. You do that work, please. 1 decimal place. This triangle's missing a side from that angle of 75 degrees. This side is opposite of my 75 degrees. This side is adjacent. Notice hypotenuse isn't even listed. So it'd be better to find a trig function that uses opposite and adjacent. That would be your tangent. Tangent of 75 degrees would be x over 21. Well, this is even a little easier than the last problem, because if I multiply both sides by 21, I get 21 times the tangent of 75 degrees will be x. You go ahead and key that in and give me the approximate answer for, I want to see both. Number 3. I'm given a small angle here, 23 degrees, and the sides that I see that are given, this 30 represents the hypotenuse because it's across the street from the 90 degrees. This side is next to the 23 degrees, so it's my alternate. What trig function is, not alternate, adjacent. What trig function uses adjacent and the hypotenuse? It is the cosine. Of which angle? of only the 23 degrees will be x over 30. Final exact answer will be 30 times the cosine of 23 degrees. You key it in. Number 4. Same old, same old. I have an angle. I have this side across the street, and I have this side that's adjacent. I do not have the hypotenuse. So I'm going to use the tangent function. Tangent of 41 degrees must be equal to 15 over x. This time, I have to multiply both sides by the 15 to get it out of here. Multiply, what did I do that for? Multiply by the x, is what I'm doing. And so I'm left with x tangent 41 degrees is 15. Divide both sides by the tangent of 41 degrees. Tangent cancels there. X is exactly 15 divided by the tangent of 41 degrees. Number 5. I'm given this angle here, 64 degrees. I'm not given the opposite. I am not given the opposite. But what I do have is an adjacent leg, and I have the hypotenuse is what I'm looking for. Since those are two things I need, that would be a cosine. Cosine of this 64 degree angle have to be adjacent over the hypotenuse, 3 over the x. Again, I'm going to multiply both sides by x and divide both sides by the cosine of 64 degrees. There's my exact answer. You need to complete it. When I grade your lecture notes, it needs to be done. Last one in this set. The small angle I'm given is this 18 degrees. Apparently, I have a leg that is opposite of it. And I'm also looking for the side across from the right angle. So this must be the hypotenuse. So what uses the opposite and hypotenuse? Sine. Sine of this small angle, 18 degrees, must be equal to 25 over x. Multiply both sides by x. That goes away. Then I'll divide both sides by sine of 18 degrees. I'm left with x is actually equal to the 23 divided by sine of 18 degrees. There's your exact. You finish it up with the approximation. Now, something a little different. You've already learned about inverse functions. Well, we can also have inverse functions when it relates to trig, but we have a name for it. And I'm going to talk about this inverse sine. If sine of theta, you have sine of something is equal to something. Sine of theta, that's my angle, is equal to some number. Then I know that x, I should say, theta is equal to the inverse sine of x. I'll show you why that's true. This -1 is really not acting as an exponent. This is just a notation for the inverse sine. It's how you can get the angle out of sine. It's how you get it out. It's the inverse operation of sine. I also like to use the word arc sine or arc cosine. So in this case, I would say if cosine of theta is x, then I can use the word arc cosine of x will be theta. That's the same thing as cosine to the -1 of x equals to theta. Inverse cosine, arc cosine, they're the same. The word arc in front of it, I just tend to like it a little better, especially on the computer when I type them in, because it's easier to type in a word than to type in something to the -1. So in this case, if tangent of theta is x, to get the theta out, I do the inverse of tangent of x. How do I use this? Why would I use this? Well, if you look at number 7, I don't have the angle. And we're looking for find theta. Round that to the nearest tenth of a degree. So our answers have to be in degrees. Make sure your calculator's in degrees. So I look at these 3 things that I have. Well, I have 2 things that are given, and I have a theta. And I look at that theta and say, well, this is my adjacent. It's a leg, it's adjacent. This one is next to it also, but it's the hypotenuse because it's across the street from the right angle. So the trig function that connects hypotenuse and adjacent would be cosine. So cosine of that unknown angle has to be equal to 18 out of 23. Now here's the magic, where the magic happens. To get the angle out of there, I will arc cosine both sides. That's what I'm doing. I'm arc cosining both sides. It's like taking the square root of a square or squaring a square root both sides, whatever the case is. What that does is it cancels each other out because they're inverse operation, leaving what I want, theta, equals to arc cosine of 18 over 23. Now, in the TI-84 calculator, if you look at your cosine button, you will see, here's your cosine button, and then above it would be the arc cosine button. So that means, and for my calculator, it's second cosine. Students showed me yesterday that when you go to your trig functions, you can just see the list and see the inverse cosine, and just type it in. Press the button, inverse cosine, and type in this whole fraction. Don't round the fraction first into a decimal and then do the work. You need the whole answer, all of the 18 over 23. Now, your answer will be rounded, and you need to put degree sign or you're going to lose credit. Number 8. Comparing this angle, I have an opposite side, or at least I'm looking for an opposite side, or I have an opposite side, and I also have its hypotenuse. I have the opposite and the hypotenuse. So that would be the equation I would set up would be sine of theta would be 5 over 21. Let me back it up a little bit. Let me put my room here. Lay some room. 5 over 21. So when I want to get rid of the word sine in front of theta, I arc sine or inverse sine of the left. Then I inverse sine of the right. Inverse sine cancels out sine, leaving theta, which is what I'm looking for, is equal to inverse sine of that fraction, 5 over 2. You key it in the calculator and get the approximate answer. Okay, there's I needed to get through that page. And by the way, the topic I was going to put is solving right triangles. That's what we're doing. We're solving them. Solving them means to find missing pieces that you don't know. Okay, let's do another one here. There's my theta. That's across the street. That's a leg. That's my opposite. Here's the other leg. but it's not across the street. It's adjacent. Adjacent. Since you're not given the hypotenuse, it's a good idea that you're using probably tangent. So tangent of theta is opposite 17 over 18. Arctangent both sides. Arctangent this side as well. Cancels that all out. So you got theta is arctangent, inverse tangent of 17 over 18. You know, I can tell number 10 is exactly the same thing. Why? I do not have hypotenuse. So why play any games? I know for a fact that theta will be the arctangent, inverse tangent of the fraction of opposite over adjacent of this angle. So that's 39 out of 20. Key it in, giving me your... All of these answers need to have a degree sign, and I should have been putting them too just to say they're all degrees. There's another arctangent. Without even doing, no, that's not arctangent. Almost got tricked. This is the hypotenuse. This is the opposite. That's going to be arc sine. Inverse sine of opposite over hypotenuse. 29 over 52 will be equal to theta. Degrees. Look at number 12. I have the adjacent and hypotenuse. What do I not have? I do not have the opposite side. Therefore, adjacent and hypotenuse in relationship to this angle would be a cosine. So I know I have theta will be inverse cosine of adjacent over hypotenuse. So you can pick up the pace a little bit. I just think it looks so much better when you literally say, when I do it as cosine of theta equals to 12 over 19. And then I'm so smart by inverse cosine both sides. Inverse cosine of both sides. That pops out, leaving theta is... Oh, why did I quit writing? Theta is inverse cosine of 12 over 19. Well, now when we get to the last 4 problems, I'm going to do 1 or 2 of these. He literally is saying, solve it. And do all your measures to the nearest tenth, one decimal point. So you have to find everything that's missing. And so 13, I'm missing angle B. I'm missing the measure of angle B. But I don't have to use trig. I could use trig. I could put my little theta there. I want to write. Come on. I could put my theta there and realize that compared to theta, I have opposite, but I don't have anything else. I cannot use theta as unknown. So the only way to solve for theta is to remember in geometry that the 3 sides of a triangle must add up to 180. So I have 1, 2, 3 angles. I'm already using up 90. So these 2 angles must add up to 90. So I know the measure of angle B would be 90 degrees minus the 72 degrees. That would be 18 degrees. So this angle is 18 degrees. So I'm going to go over here and put measure of angle B is 18 degrees. Now that you have that, you can find any of the other 2 sides you want. Takes not enough room to do all of this. So if I'm looking for CB, that side, which I'm going to use the 72-degree angle, so that becomes the opposite side. CB is the opposite side. And then I'm going to use 15 as the adjacent side. So to find out CB, I can literally say, that'd be a tangent function. Tangent of the 72 degrees must be the opposite side, which is, he's calling it BC. I said CB, over the 15. Yeah, that's my adjacent side. So BC will be 15 times tangent of 72 degrees. That's my exact answer. And the unit doesn't have any units because he didn't label any of the measurements, and we're not doing it. It's not an angle. So you go ahead and key that in. And then I'm missing one other side. I'm missing the hypotenuse now. If you don't want to do trig, you can do Pythagorean theorem. Because you just found that we have the 15. You just found this answer here. You can literally say 15 squared plus the BC squared, because you just found it, and the other problem will equal to the AB squared. You could do that. If you don't want to do Pythagorean theorem, we could do it by using, let's see, adjacent over hypotenuse, that's this. If I'm using the 72, adjacent over hypotenuse, you could do the cosine problem. You could say cosine of 72 degrees is 15 over AB. AB multiplied to both sides, then divide by the cosine of 72 degrees is 15 over cosine of 72 degrees. That would be your AB just as well. You got AB from here, you got AB from here once you solve it and get the square root and all that. But I like the trig better. I just think it's cleaner. But you have two choices. Okay. If I'm doing 15, I would, I don't have either angle, guys. I don't have this angle or this angle. So I don't have any magic subtract from 90. So you're going to have to find an angle first. So in this case, since I have, with a measure of angle K, I can literally say that this is the adjacent and this is the hypotenuse for angle K. So I'm going to say cosine of K must be 7.6 over 8. Second cosine, arc cosine, inverse cosine, whatever it is. I know that K, the angle K, will be the inverse cosine of that fraction, 7.6 over 8 degrees. You're probably going to round it to 1 decimal place. Now you'll have an angle there. And so if you want to find JL, that's opposite of the K. So I could go and write to the mode and say sine of K must be JL over the 8. Well, we already know JL. No, we don't know JL, but we know K. So we already know K because K is coming from here. So that answer would be 8 sine of whatever that angle was that you found would have to be JL. So now I found JL and I found the angle K. Oh, we don't have angle L. Well, you do now. Angle L and angle K both have to add up to 90 degrees because this takes up 90 and there has to be 180 degrees in that triangle. So I know the measure of angle L will be 90 minus the answer I found at the beginning of angle K. That will be in degrees. 90 minus that first answer gave me the angle L. All right. You got a lot to do. There's no extra homework on this right now. You guys that did not finish up your homework from the other day, you need to get it done. Any newbies that I've gotten in this week, you have to do both lectures. You'll have to do trig ratio lecture and do those notes. That's where homework 4 comes from. There's no homework from here. And a Khan Academy will be assigned by today. It's a small one. It'll be due next Friday. All right, guys, have a good day.